So we're going to look at Lab 10. So there's a video on Lab 10 explaining how the data was collected, and then you also have a copy of the lab with the part of the data table filled in. So what I wanted to do was supplement that and kind of go through exactly what you need to be completing on the lab and how to do so to try to kind of answer any questions preemptively. So what I have here is data table 2. And notice I don't have all the columns, I just have 3 of the columns present. The first one being accelerating force measured in newtons, and you'll notice that column is blank on your lab, so that column you need to calculate. All right, so to calculate the accelerating force, you're going to be using the gravitational force equation. So this is essentially F of W, the weight force. So to calculate the weight force, you're going to take the mass times gravity. So in the data collection video, you'll notice there was a hanging mass that was hanging over the side of the air track. And what was affecting that mass was gravity. So by multiplying those two, you're going to be calculating the force that was being used to make that glider move across the air track. So you're going to use this equation for each of the 5 trials and fill in. So since every trial had a different mass, every accelerating force should have a different answer as well, a different value. For the average time column, so that's the other column that's blank, to calculate the average time, you need to take the 3 trials of time, T1, T2, and T3, and divide that by 3 to get the average. Make sure if you are putting this entire thing in your calculator that you do parentheses around that addition on in the numerator. So you will fill that in for all of the 5 trials as well. The last column on the data table that you need to fill in is the acceleration column. And this is the x-axis on the graph provided. So what I did was I took an equation from chapter 4, the distance is equal to 1/2 AT squared, and I rearranged it to solve for A. So to solve for A, we're going to do 2 times the distance, and the distance is 0.5 meters for every trial, so the distance is the same in every trial, but the T average is going to be different. So I want you to take that T average that you calculated in this column over here and square it in the denominator. So for each of the acceleration calculations for all 5 trials, you'll take 2 times the distance divided by your average time squared. Don't forget the squared portion. So what I did with the graph, so the graph has been provided, you don't have to graph it, but I took these accelerating force values, and those were my y-axis values, and then I took the accelerating force values, and these were my x-axis values. So I have a similar diagram to what you will see on the provided graph, having the force on the y-axis and the acceleration along the x. And from this, what you need to do from the graph is calculate the slope. So a little reminder on how to do that, because I noticed there were some troubles in the lab 7 with calculating slope. So I just wanted to do a little refresher here as well. So you need to pick, the important part is you need to pick 2 points on this line, okay? And in the graph I provided, I only went through maybe 1 data point, okay? So you cannot use the data points to calculate the slope. You need to pick points that are present on the line. So pick points that are easy to read. So I'm going to pick, say I pick this point here. So this will be my first point. So my x1, my y1. So this first point, to figure out what x1 and y1 are going to be, I'm going to follow this point all the way down until I hit the x-axis. Whatever value that is reading on that point on the x-axis, that is my x1 that I am going to plug into this equation right here. I'm going to look at that same point, and I'm going to follow it over till I hit the y-axis. Whatever value it hits along the y-axis, that is my y1. So x1, y1, these are going to be the two values that I plug in here because this is my x value for data point 1, my y value where it hit on the y-axis for data point 1. I then need another point. My second point will provide x2 and y2. So pick a point that's on the line, follow it down and across. So following it down until I hit the x-axis, whatever value it hits upon is going to be my x2. And I'm going to follow it across that same point until it hits the y-axis, and that is going to be my y2. So this will be x2 and y2, which we will plug in for the other 2 points in that equation. So calculate and solve. Make sure you have parentheses around both the top and bottom portion. So why are we calculating slope in this experiment? We're calculating slope. Let's look at the units of the slope. So that's going to help us understand the y. What does the slope mean? Okay, so slope is change in y over change in x. So we have y values on top and x values on bottom. But what is y? Well, to figure that out, you look at what did you plot on the y-axis. Okay, the y-axis was the accelerating force. So it was the force. What are our x values? Those are all representing acceleration. All right, so force is measured in what? So we're looking at, remember, units. It's measured in newtons. Our acceleration is meters per second squared. Okay, so let's take this a step further. What are newtons? Okay, so to figure that out, I'm going to go back up here and I'm going to look at force. So force, we said, is measured in newtons, right? Force, newtons. But how do we calculate force? We take mass, in this case, and we're multiplying it by gravity. So what is mass measured in? Mass is measured in kilograms, because every time we use mass in any of these physics equations, we've been converting it to kilograms first. Gravity then has the same units as acceleration, and it is measured in meters per second squared. So newtons is really the same as saying kilograms times meters per second squared. So I'm going to substitute this n that's in the numerator on top for kilograms times meters per second squared. And then on the bottom is acceleration, and the units on that, remember, were meters per second squared. So looking at this equation, can we cancel anything out? What it has in common is I have a meters per second squared in the numerator on top, and I have a meters per second squared in the denominator on bottom. So if they're on opposite sides of this horizontal line, they cancel. So when I'm calculating slope, what I'm really calculating is just the kilograms. And what is kilograms? Kilograms, we just said, is a mass. So I'm calculating the mass of the system by calculating the slope. So we're going to be using this to do a percent error calculation. And what we're doing the percent error of is we're going to compare the total mass of the system, which is given to you in data table 1, to the mass we calculated in the slope. So to do that, we're using our percent error calculation, where we take measured minus true. These are absolute value signs, so it's going to be a positive number no matter what. If you get negative, just change it to a positive. And then we divide that by the true value and multiply by 100 to get it into percent value. So what is our measured and what is our true? Our measured is the slope that we calculated down here. Picking 2 points on the line, getting our x1 or y1, our x2 and our y2, and plugging that in. Okay, so the slope we got is the measured mass of the system. The true value of the system is the actual mass given in data table 1. I do want to point out that notice in data table 1, you are given the mass of the system, the true mass, in grams and kilograms. So make sure that you choose the correct units when you plug it in, because you are comparing these two, so they need to be in the same units. Okay? So you're going to calculate how far off we were with our slope calculation compared to the actual mass given to you in data table 1. Now everyone should be getting similar slopes and similar percent errors because we're all using the same graph and the same data. So let me know if you have any other questions, and I will answer them as best I can. I hope this helps you finish. It should help you finish not only the data table and your calculations, but it should help you answer the questions as well.